Okay. So listen, today we would like to see the production of electricity, how the electricity is produced in a conventional way. I mean, the basic principle of a generator, how it works. I mean, if you think about how the other form of energy, actually the energy basically comes from the sun.
Yes.
If you think about all the energy available in the earth, which all comes from the sun. So in the sun, how the energy is radiated, the energy is coming in form of radiation. The sun has, if you think about the sun, inside this there is a kind of reaction, nuclear reaction takes place, and the hydrogen, which is the very first thing that is created. The first atom created was hydrogen. Hydrogen, yeah, this is H2 is the hydrogen gas, which is the form of gas.
First
And
atom
if you think
made
about
for
water,
generation.
a part of the water is hydrogen as well. H2O is the
It's water.
water, right? Yes. So let me tell you.
So the first atom made for generation for this hydrogen
Hydrogen, right?
from the sun, the internal sun.
Yeah. Actually, the energy that is created through the Big Bang, we call it Big Bang. There is explosion that took place maybe 12 billions years ago, which is
Explosion.
yeah, which is too early. And after that, the hydrogen created, and then the energy has started to radiate from the sun. So the temperature of the sun is too high. So energy is radiated in two forms. One is the form of light, another is the form of heat. So we get the energy here in two forms. If you set yourself out there in the field, you see, you feel a bit heat,
Yes.
right? That is your energy. And also, you feel a kind of light, right? That's energy. So exactly, the energy can be transferred from one form to another form. The heat can be transferred to electricity.
First equation.
Yeah.
When the sun has the light,
Yeah.
that light is continuous for heat. So you
No,
see,
actually the sun releases its energy, radiates its energy in two forms. One form, because there is always a kind of nuclear reaction taking place in the sun, inside the sun, which is in the there is an area there. If you just walk on the sun, you see that there is a two separate areas, the core and the outer part. So in the two separate parts, there are several things takes place. So hydrogen is always converted. This hydrogen is getting converted into helium and releases huge amount of heats. This heats is energy. At the same time, the temperature of the sun surface is maybe 1600, or sorry, maybe 800 or something like this. I forgot it. It's too much. 8 into 10 to the power 16, I guess. Something like this.
that number
This is the Kelvin. The unit of heat is Kelvin. So which is too much, because after 10, after 1 there is a 16 0, right? So this is a huge energy in the form of heat. And then also light, another form of heat is light, energy is light. So these two, lights and heat, both are radiated to the entire, the solar system. So the Earth is a part of solar system. So Earth just takes, which is maybe third position. The first is, our planet is at the third position in a sequence, right? And if you look this, okay, let us see how so this energy is being translated to the available form of energy. Maybe the plants, right? The grasses. There is a process. Through this process, they convert this energy available from the sun into the form of stars, right? Which we take as food. That is the energy. And the other form we can take directly from the photon, because the light is a composition of photons. right? So these photons are basically once the photon hits over the panel is made of semiconductor. You know, we learned the semiconductor in electronics, which is p-n junction. I talked the other day.
Yeah.
The p-n junction. You can make a p-type material, you can make an n-type material, and you can take them together. Yes?
With
Yeah, repeat.
yeah.
Okay. So actually, do you understand solar panel? Solar panel, you see the solar panel which is
Yes, I
in the
understand
top.
it.
Yes, sun. And they
They
take
absorb
energy-
it,
yeah,
the light.
light, right. This solar panel is taking energy from the sun directly.
Directly.
Right, yeah.
Okay.
So actually, this is exactly the non-conventional way of producing electricity. But there is other form of producing electricity, which is called conventional way. The way that has been adopted for long years, very many years, perhaps 100 years, we are producing electricity the way.
That way is correct.
Conventional way. Conventional, the way it is used to be. Exactly
We
conventional.
use for 100 years. We
Maybe
use
100, because
in the best way for generate the sun.
yeah. Actually, no, it's not it's not directly from the sun. It's indirectly from the sun, because the energy from the sun is absorbed in the plants as a form of stars, and we also are eating those things. We are eating maybe meat. We are eating the vegetables, right? Which are all energy absorbed from the sun. And once we die, maybe we die and we got under the earth, right? We got mixed with the earth. So this energy that we absorbed for very many years during our lifetime is being in the earth is being converted, decomposed, and then maybe perhaps 100 years later we will become gas, will become fossil fuel. The fossil that is available today was a kind of plants, kind of people, kind of animals, the mammals that extinct, that got destroyed maybe 200 or 300 or maybe perhaps 2000 or 3000 years ago. And those things are actually the energy. And we are taking it out as a form of liquid, which is called oil, the form of
The oil, the
Yeah.
first it come for the human. When they
human
destroy
animal,
after
there are other form of thing that was also small living organism, microorganism, which is zooplankton, which is available in the ocean floor, which is diatoms or diatom, very small kind of living organism. When they die out, they got the ocean surface. Some of them got mixed to the water, the ocean floor, and they just moved to our area, right? Different areas, and they, then the sediment, the sediment, covered them with up. These, there are different layers produces in it, and they become a form of gas. They become a form of oil or coal, and we are extracting this, and we are distributing this among the different places of the earth. So this coal, this oil are the source of energy, and this energy came from the sun directly. But once we produce energy from the coal or from the what do you say, a form of oil, that is the energy, is the secondary energy. Yeah, the primary energy would be the taking energy directly from the sun. We're getting directly. Maybe solar panel, right? Maybe the way the plants produces energy in a form of starch, right?
Yes.
So exactly this process taking place every day. But once you collect energy from the fossil fuel and produce electricity, how? Today we would like to learn how we are producing electricity using fossil fuel. Exactly there.
Fuel is fossil.
Fossil. It's a fossil. F-O-S-S-I-L-E. F-O-I-L, I guess, or something like this.
No problem.
Which is the thing which we just extract from the ground of the earth. inside the earth, maybe perhaps
It takes for energy.
Yeah, they're always in the form of energy. So fossil fuels are the coal. You might see coal, you might see oils, then
Period. For
gas. These are the thing. Fossil fuel.
fossil fuel.
Fossil fuel. It's called fossil fuel because this has come from the plants. They got under the earth. Maybe thousands years ago, they died and they became a kind of this form. You understand?
Yes. Today we are we learn.
Maybe 5,000 or maybe millions years ago,
Okay.
a person died.
Okay. Today we learn how to make
Electricity. From this form. Actually, you see, the people maybe 5,000 years ago,
Yes, they like.
they took energy from
Sun.
the available, the sun, the tree, maybe tree. This is a tree. The sun is taking energy from the sun,
Yes.
and the people around or animals were available.
They
They
eat
get that energy,
Yes.
and they store it in their body,
Yes.
right?
Yes.
And they died,
Yes.
and this energy, the bacteria decomposed them and just mixed with the earth, available soil.
Yes.
And after 1,000 years, this energy becomes this form of energy.
Yes.
You understand?
Yes.
Which we know as hydrocarbon as well. So we call it hydrocarbon.
Okay.
Yeah? Okay. Let's see. And okay, where is the dust? Now let's see how the energy is produced. The electricity you see, how that can be produced using this fossil fuel.
Okay. The first tool we tell how to become electricity and generation.
Okay, well, I'm explaining. Hey, listen, if you find difficulties in understanding, obviously, you let me know. Okay, listen. The first thing, the worldwide the electricity production is denoted by E.
I know.
E is equal to E is the electricity.
Electricity. Also denoted by I.
Yeah, I is exactly. E stands for electricity. I is also symbolized in terms of mathematical equation, right? When you learn about Ohm's law, I is symbolized, but E is also denoted by the law. I mean, let me explain.
Okay. Law means law.
Law is maybe Ohm's law. Ohm says the I is equal to I is proportional. Okay, I is equal to V over R. That's the Ohm's law.
So.
Okay,
Formula.
Ohm's, George Simon Ohm's, who discovered this law, there is a relation between the current, voltage, and resistance. We'll learn about this. So I is symbolized. The current is
Also
symbolized with
E.
I. Voltage is symbolized with V. But when you see electricity production, then the electricity is symbolized as E. E means electricity.
Oh,
The first
understand.
thing is
Understand.
taken.
Yes.
Okay. We are just taking the first. Okay. So we would like to verify today the Faraday's law of electromagnetic induction, which is the basic fundamental way by which the electricity is generated. Everywhere, every generator you see available, producing electricity, maintaining this law. Faraday's law of electromagnetic induction.
Right.
Okay. Faraday's law of electromagnetic induction. That's the name of the. Actually, a scientist who discovered this, who observed first
Electricity.
that how can electricity be produced, right? That is why he, in respect to his name, called it Faraday's rule or Faraday's law.
Oh,
You understand?
yes.
This is Faraday's law of electromagnetic induction, and I will explain what induction is, what electromagnet is, everything I will explain.
Okay.
Okay, but first let us understand what the law is, right? What he says,
Okay.
what he exactly states, that what is the
Would he
thing.
believe it for this one?
Yeah, what he believes exactly.
For the electricity.
Yeah.
Okay.
Okay, let's see. So the generated electricity would be E,
I just said.
which is equal to two things: N d phi over dt. So forget about minus first. I will explain it later on what minus is.
Okay.
Okay, so we can erase it, right? Okay, you can keep it, doesn't matter. But we'll work on this. When you think about the electric generator, once Faraday discovered it, then people have started making generator. The electric generator. Before this, electric generator was not there. Once this law is discovered, this relation is discovered, then people have started giving a physical shape of this machine. This is a machine. This equation will be converted into machine, let's see. And this machine, the output of the machine will be like this. Okay. Where is the sun is giving the light, the flow of electron directly?
This light?
Yeah.
No.
No, it's not giving. Somewhere it is produced.
Yes.
We call it power plant, where the electricity is generated, right?
Yes.
With what the electricity is generated? A generator.
Yes.
An alternator is exactly generating the electricity.
Yes.
And it is transmitting and distributed in the different areas.
Like this.
Yeah, and that's we are the consumers, and we get distributed the power. As consumers, we are just using the power, but this power is generated in a remote area, in a distance, and they generated there with the help of generator. And today we are learning about what the generator is, how they make the generator. You understand? How they produce electricity in the generator. Because there is no
Generator, he done it. Generator.
Actually, in the we use the energy of the sun. How? The fossil fuel, maybe coal,
Yes.
maybe oil,
Yes.
right? Maybe gas. These are the things we extract from the earth's
Yes.
ground,
Yes.
and then are they electricity?
Yes.
No, they
No,
are
no,
not
no, no.
electricity.
They are producer of electricity.
Yeah, they're the
Yes.
source of electricity.
Yes.
They're source of energy,
Yes.
and we produce electricity from them.
Okay.
So now I'm showing you
Okay.
how can
I understand for you. Gas, oil, coal will convert to electricity.
Yeah,
Because
we
this is
convert,
energy.
right.
This
We
is
convert.
energy.
These are the source of energy, and this energy
We convert to
this
electricity.
energy exactly first they burns. The first thing they burned it.
They must bind.
Yeah, when they burn, then heat produced. Once you are burning something, you see heat produced.
Yes.
Right. So when they burn these things, heat is produced.
Yes.
So this is the chemical energy. The energy in this thing is in the form of chemical,
Yes.
because you see the oil, which is hydrocarbon.
It's liquid also.
And if you see the gas, which is C is for methane gas, right? Two different gas, C6H4, and then methane, ethane,
Yes.
propane,
But
butane.
butane,
Yeah. I think in the chemistry you learned it, right?
Yes.
So these are the chemical energy. All the energy is what? In the form of chemical energy.
Yes.
And when you burn it, this energy will be
Heat.
heat. That's called thermal energy.
Thermal.
Thermal energy, right?
Yes.
So the chemical energy will be first converted into thermal energy.
Thermal.
Then this thermal energy.
Right.
Okay, I'm writing thermal. THERMAL.
Thermal energy.
Thermal. Wait. Got it?
Then.
Hey, do you understand everything?
Yes.
Okay, if you do not understand, you must ask. Keeping silent in the class, that means you do not understand thing. Okay, listen. The thermal energy, so that's why it's called secondary energy. We are getting energy, electricity as secondary form. Because first it was chemical,
Second.
then we burn it, it becomes thermal,
Heat.
and from that thermal, it is becoming electricity. Right? So how? Let's see. Do you understand the point?
Yes, that I done very well.
Okay. Here you see, once Faraday discovered what Faraday says. Let me explain. Faraday says that the electricity in the generator, the electricity that is produced, would be equal to N d phi over dt. And now we have to understand what N is,
What's DQ?
what d phi. This is phi. This is called phi.
Phi.
The symbol is this. Okay, you may give a kind of thing like that, and then make a thing like this.
Phi.
This is called phi, right? If I guess you may pronounce like this, phi.
Okay.
If I, that means p. This one.
DT.
If y, you make it. Okay, whatever. Phi. This is
Phi.
called
It's called
phi.
phi.
I think if a I is better.
No problem.
Phi.
Yeah.
Okay. So this is phi. is, okay, now let's see what the N is available and what the phi is available, right?
Okay.
We are coming, listen, we are in the electricity production right now.
Yes.
We are not letting ourselves there. We have done it, we've seen it, the word
Yes.
this singer, how this is.
This is electricity.
Yeah. This is how can we use this to produce electricity.
Yes.
Right now, we'd like to know. Let's see. Yeah. So N is called, okay, how can you make N? Huh? Okay. Have you know, okay, I talked about the copper wire, right?
Yes.
Can you give me this wire? The wires available? Give me the wire, right? Yeah. Give me the wire. I'll show you how N is produced. Okay. Okay. So basically these two are the arrangements. Two different arrangements. First arrangement, when you have the wire with you, this wire, look at them. We are now making N, right?
Yes.
So N, if you think about this, N. So inside there is copper, right?
Yes.
What is that? Copper, which is conductor.
Yes.
We learned about conductor in the
Yes,
last class.
very well.
Yeah. So this is copper inside it.
Yes.
So when you have the copper like this is called number of turn. Okay. This is one turn. This is another turn. This is another turn, right?
Yes.
So this is lots of turns are there, and this is called a coil. What?
Echo.
Coil. Coil.
Coil.
C-O-I-L. Coil.
C-O-I-L.
Coils. I mean coils. You
When
see,
when they make for more. This
yeah, more. They makes a coil.
Okay.
Coil of copper wire.
Yes.
So not right now it's copper wire, but not a coil. Once you have lots of turns out there like this, it becomes a coil. You understand?
Yes.
So this wire can be make a coil, right?
Yes.
Coil of, okay, right now there is no turn,
Yes.
but you can make a coil of maybe 1, 2, 3, 4, 5, 6, 7, 8, 9,
This is
10.
coil.
Okay, and right now it's called coil.
Coil.
So this is the coil of, how many turns have given? 10, right?
10.
So the
Yes.
value of N would be 10 here.
10.
So N is what? The number of turns we give.
Yes.
A copper wire, so normally wire is available everywhere, right?
Yes.
So you can take a piece of copper wire
Yes.
and you can make some turns, right?
It's up to you.
Right?
To do with everything.
What?
To make it for.
Yeah, coil. Just take a piece of copper and make some coils,
Okay.
right? So once you make the coil, that would be your N. So right now is that okay?
Okay.
What is
now-
N?
Yes, I
So
figured.
N is very much easy to make, right?
And it's to make it for a
Coil.
time.
Yeah. N is the number of turn exactly.
Yes.
N denotes for the number of turn. Okay, let's see. Number N is equal to the number of turns. T-U-R-N.
Okay, so,
Yes.
so if I, example, if I done this one, this is one,
This is one
this
turn.
also, I
This
have
one.
2 turn.
When you give 2 times,
2 turn.
this is 2 turn.
2 turn.
When you give 3 times, 3 turn. 4 times, 4 turns. 5 times. Do you understand?
Yes, very well. End
So-
of the time.
Okay. So the number of turn is, to make the number of turn is very easy, right?
It's very
So we
easy.
learned about just half of the total process.
Yes.
Huh? How we can have the number of N. I mean the N. We have already had the N, which is number of 10. Just you take a piece of wire and make some turns. That makes you N.
N.
Right? Okay. Now, so we have had our N. Now let's come to know what is d phi over dt. Right? What is d phi by dt? Okay, let me show you what is that. Let's see. Phi. Let us come to know about what phi is. Phi is exactly called is the amount of it is also known as flux.
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 Yes.
Okay, flux. F-L-U-X. Flux. Flux is, if you see magnet, have you seen magnet?
Yes.
Have you ever seen magnet?
Yes.
Yeah, that attracts.
Yeah, thanks.
So magnet has got north pole. If you have problem, you may get yourself to backside, right? But so let's see. The magnet has got 2 things:
Yes.
a north pole and a south pole. Every magnet has got 2 poles. One pole is north pole, another pole is south pole, right?
Every magnet.
Yeah, every magnet. So north pole, there is a magnetic line of force. You know why magnet attracts? I told you in the very first class there are 2 types of line of force.
Yes.
For magnet, the magnetic line of force, that's why they attracts or repels.
because they have some charge,
Yeah,
positive and negative charge together.
yeah.
They
that
make
is-
attraction.
that is in terms of electricity,
Yes.
charge. But this is magnet. That was electric line of force.
Yes.
This time we talk about magnet.
Yes.
You know, these two charges attracts. Also, the two pole of the magnet attracts.
Yes.
Right?
Yes.
So, two charge attracts because they have electric line of force.
Yes.
And two pole of magnet attracts because they have another kind of line of force, which is called magnetic line of force.
Yes.
So the magnetic line of force always traveling from the north pole to the south pole of the magnet.
Yes. They go some direction.
Yeah.
That's why they make power.
So this magnetic line of force of a certain area, maybe this area, is called phi. Now do you understand what phi is?
Yes.
First, where phi is available? Around the magnet.
Yes.
Phi is available where?
Magnet.
Around the magnet. I mean, if you have a magnet, around the magnet there is something. You know,
Phi.
obviously, around the magnet there is something. There is a two same magnet, same pole repels, two opposite pole attracts, right? There is obviously something that makes the magnet behaves like this. That is the magnetic line of force around the magnet. And the magnet has got two parts, not two poles, north pole and south pole. And two same pole repels. Two same pole of a magnet repels each other. And two opposite pole of magnet attracts each other. Do you understand? And the reason is similar. Why? Because when you have, okay, I'm explaining why the two same pole of magnet repels and two opposite pole of magnet attracts. Let me show you. If you have another magnet here, maybe south pole and north pole, right?
Yes.
Once you have two poles, so now these two poles of the two magnets are similar,
Yes. They
right?
are same. Yes.
Same. And what do you think? What should they do?
They are rebel
Repel.
because they are same.
Yeah. The reason for repelling is that, listen, for this magnet, the magnetic line of force is working here in this direction, right? Because the line of magnetic line of force starts from the north pole always
Yes.
and ends at south pole. So for this magnet, the magnetic line of force is coming this way, right? So and reaching to the south pole this way, right?
Yes.
The direction is this because it is coming starting from this. This is the direction. It is coming in this and starting, ending in this side.
Yes.
And for this magnet, from the north pole to the south pole in this direction, right?
Yes.
So if you see the crossing point of the line of force, what will happen? For this magnet, it is coming towards this direction,
Yes.
and for this it is coming. Oh, sorry. For this magnet, it is coming at this direction. So what happened? For this, the magnetic line,
They rebel
yeah, they repel. The reason is
because they go different direction.
at the crossing point, they see the opposite direction. They walk in opposite direction because this is going to this way
And this go this
and
way.
this is going to this way. Because this starts from for this magnet, it starts from this and come in.
Okay.
And for this, it is also starting from here and come in that direction. At the crossing point, you see this one is working in this direction and this one is working in this direction.
Yes.
So the direction of magnetic line of force is opposite.
Yes.
That makes them repelling. Understand?
Yes. We know.
Okay. If we would have
And
north pole here rather than south pole. And now I'm explaining why they attracts.
Yeah.
Why the two opposite pole attracts. I have just explained that why the two same pole repels.
yes.
Now I'm explaining what?
One of them make rebel.
Yeah. We just have seen the why
They make rebel.
they make repel. Now we would like to see
Why
why
they-
they make attract.
Attraction.
Okay. Let's see. So when the attraction may take place, if we have opposite poles, right? So if you have a south pole is already there.
Yes.
So if we convert this magnet having north pole here and south pole here,
Yes.
right? What happens? For this magnet, the previous thing will happen. I mean, the line of force start from here and comes in here, right? And what will be for this magnet?
You go the source.
It will also start from here
Okay.
because this is the north pole. So start from here. So look at the crossing point. For this magnet, the line of force working in this direction, and for this magnet, the line of force also working the same direction. Both of them, look, they go this way, and for them, this one is going the same way. Okay, I'm making it clear again. We understood the why
Yeah,
two
make
same
repel.
pole repel,
I
right?
understand that.
And we'd like to see why two opposite pole attracts, which is maybe south, okay, north and south. And once we place here what? North and south. So these two pole opposites, right?
Yes.
And they should attract
Yes.
because they're opposite pole. And the question is why they attract, right? When two force work in the same direction, only then they attract. We have seen in the charts, when the two charts working with the line of force due to the charge, positive and negative, when the line of force was working towards same direction for both,
Yes.
like then they used to attract, right?
Yeah, attracted. Yeah.
This way, towards the negative, they attract. That
Yes.
means the condition for attracting is what? The
Same-
line of force has to work in the same direction,
same direction.
right?
Yes.
But they used to repel when the line of force
Yeah,
outward,
outside.
opposite, and they used to repel, right? So here, for when it was south pole and north pole, we have seen the line of force working opposite, because if you see, from line of force start from north pole, right?
Yes.
So it starts and coming here, this direction, right?
Yes, very well.
And this one, from this one is also starting from the
For
north pole
outside,
and come back here.
for
So you see the direction is this.
difference.
So direction is opposite.
Yes, very
Because
well.
for this the direction is this way, and for that the direction was that way. So the
Yes.
direction of line of force is opposite.
Yes.
That is why they used to repel,
I understand very well.
right?
Yes.
Okay. Now they will attract when the direction of both are the same, right?
Yes. Yes.
So if you place a north pole here and south pole here, what will happen? For this it is okay. The direction of force is okay.
Okay.
But for this now, what will happen? The line of force is start from here because this is the north pole.
Yes.
Huh? So if we start here, right, like reaching here, that means the direction is which way?
Yes, the same way.
Hmm?
Same way.
The direction is here. If you look at the, let's see, here the direction is this way, right?
Yes.
And for this, the same direction. This is also going this way, towards this way.
Yes.
At the crossing point, if you see, for them, for north pole, which is reaching to the south pole, here on the for north pole, which is reaching to the south pole. So both of them will going this way, right, from north to south.
Okay.
So that is why they attract, because both of the line of force for both line of force for both magnet works in the
Direction.
same direction.
The make attraction.
Yeah, they make
I
attraction.
understand.
You understand?
Very well. Very well.
Okay, that's good. And the other thing that we see here, so that is the reason the two same pole of the magnet attracts, repels, and the two opposite pole of the magnet attracts. Understand?
Yes.
Now, this was the law. E is equal to minus n d phi dt. So we have seen the n, right?
Yes, very well.
And we talked
see
about phi.
phi.
So phi is this. What is the phi exactly?
Phi is the
Phi.
magnetic around it.
Line of force, magnetic line of force around the magnet is the phi.
Yes.
The amount of the magnetic line of force of a certain area, the amount. Okay, let's see how. So for this magnet, the line of force is working this way, right?
It's a phi.
Yeah. So
That line is called phi. That
yeah.
line.
These lines of certain area is called phi. You understand?
Yes, very well.
Now our job has to see the phi directly. Have you ever seen the phi around the magnet ever?
Yes.
Where?
What?
In your home? Where have you seen the phi? We talked about the phi. This is phi, right?
Yes.
The magnetic line of force of certain area is called phi.
Yes.
Have you ever seen it?
No, but I will say I understand it.
Yeah?
I never see it.
You never see it.
Yes.
So why did you see
But
it?
I see chemistry
Okay,
also.
so now I would like to show you the phi. Come here. Bring this one. Bring the no, the meter and then that one. Bring them both. Yeah. Come. Now I'm going to show you the phi, right? So stand here. Look at this. This is okay. Keep it here. Do you see this one? This one is a magnetic Swiss. What? Magnetic Swiss. When it has got phi around it, this Swiss will work. And when Swiss will be on,
Yes.
MS means magnetic Swiss.
Yes.
Okay. When there is a phi available, the flux line of force, the flux is available, then only then this Swiss will be on. and when there is no available flux, it will remain off. Understand?
Yes.
Okay. So for now, we will have to check, right? Okay, I'm showing you something from the meter. Oh, this meter is not going to work.
I will try to repeat.
Rakit, can you give me this meter?
I will try to repeat this one.
Let's see. I will explain. What happens if you run slow? Tell me. Tell me again.
Okay, this is the magnetic line.
This is a magnetic switch.
Magnetic switch means
Switch means we are pushing switch.
off, on.
Oh yeah. So this switch will be on when there is a magnetic line of force. When there is a phi available.
Yes. Okay, I understand. I repeat it.
Yeah.
This is a magnetic switch.
Yeah.
When is available line of magnetic, it is on.
On, right.
When is a magnetic of line is off, it's not available.
Oh, yeah, it's off.
It's off.
Yeah. You understand?
Yes.
Okay. So right now our job has to be to see where the phi is there, right?
Yes.
How far the phi stays, because if this is a magnet, how long the phi stays? Till the
Longer or near?
longer, how long it is? Maybe it is up to this, or up to there, or even to the infinity, right? So there is a certain area up to which there is a phi, right? So up to which area there is a phi, we would like to see practically, right? Okay, let's see. So hold it. I'm just showing you. Here, there is. Let's have a continuity test. Look at this. I will teach you how to make. Once we make the connection, let's see, connection, it makes sound, right?
Yes.
When there is no connection,
It's no sound.
no sound. That means when the switch is on, it will make connection. When the switch is off, it will make no connection. Okay. So it is true for now. We have seen it. But once we make connection,
The sound is off.
sound is off, on.
On.
So if we make, if I touch these two portion, is that on? Is that make connection?
No connection.
No. But when they are together, they make connection. So if I am placing the this between these two, there is no connection.
Yes.
Got it?
Yes.
That means switch is off for now because there is no flux.
No flux.
So we have to see where the flux is available, and we came
For
to know
this and for this one.
phi. Yeah, same.
Yes.
Where phi is available, right? So we came to know so far what the phi is available where around the magnet.
I know tomorrow it is.
Yeah. If there is a magnet, there is a phi, right? Okay. Rakit, can you give me the magnet? Okay. This is a magnet. Okay, give me that magnet. There is another magnet. Okay. Yeah, this one is a magnet, right? Oh, you say. Okay. So this one is a magnet, right? So as per my space, as per our observation here from this, there should be a magnetic line of force here, right?
Yes.
Huh? Here,
We
here.
found
There should be phi here, right?
Yes.
Okay, let's see whether there is a phi or not. Okay. So your job is to place it here. Okay, I'm placing the meter. I'm placing the meter. And your job here. And your job would be, I'm holding it here in between. There is no connection so far, right? Next to it, right? So I'm placing this magnet close to this. Let's see whether there is any phi or not. Okay.
প্রতিদিন কি তিনটার বেশি তিনটার বেশি
No, it's
প্রতিদিন
nothing okay. Let's see.
Okay. It's okay. It's okay.
হ্যাঁ
Let me bring the thing close to this. You see?
It's now fine.
When there is a phi, yeah, this is phi.
পরে একদিন
The
ধরে-
phi is available, but we cannot see this. We cannot see the phi. The phi is here, but we cannot see. So you have to believe for now that there is something around the magnet. Due to this, it is working. Let's see again. Do you want to see this? Okay. Okay, I'm holding it. Let us see. I don't. You just put it in the same work similar way. Okay.
Yes.
So how long the phi is available?
For
Up to maybe 1 centimeter or 2. No, not over this way. Opposite way. Maybe up to this, right?
Yes.
If you get yeah, no maybe up to this, right? So up to this area there is a phi. So have you seen the phi here?
Yes.
Okay. Go. I'm explaining other thing. So is that clear about phi?
Yes, it's very clear.
Very clear. So now we have seen phi up to this, right?
Yes.
So we have found phi, and we have seen the n as well. Now what is d phi by dt?
Yes.
Right?
Okay, so it's a question. What is a D?
Huh?
D, what is a D? What is the meaning of
Okay,
D?
D.
Yes.
Okay. d dt is a mathematical equation that tells you that something is changing with time.
Listen, listen, simplify by
Okay,
listen.
maybe me, Shuhag, staying here.
Yes.
Right now, I'm just Shuhag. Okay, now what does d dt Shuhag means? d dt Shuhag means I'm changing with the time. I'm changing my position with the time. Now I'm d dt Shuhag. I'm changing.
So every time changing your distance or your area.
Yeah, I'm changing my position. Maybe I'm here for
Sometimes
when it is 0,
Yes.
and when it is 1 second I'm here, and when it is in 1.5 second I'm here, when it is on 2 second I'm here, when it is 3 second I'm here, like this. I'm changing my position with time. So anything changing with time is referred to dt.
D divided by dt, they tell for us the
That
value for
anything
the
changes.
position.
D refers to time. T refers to time.
Yes.
You understand?
D is change.
Yeah. If anything changes with an angle, then it would be d theta. That means anything changing with an angle. Anything changing with a place, d may be place with something. You understand?
Yes.
D dt means d over dt. That means anything changing with
Position.
not position. Anything changing with time. The position is changing with time.
Yeah, okay.
Yeah? The position of anything is
Everything you
changing
did at the time is D
with d dt. You understand?
Yeah.
Is that clear?
Yes, brother.
So that means then what would be d dt phi? What would be now? Okay, d dt is okay. D over dt is, that means anything is changing with time, right?
Yes.
Huh?
This time.
Okay. Anything is changing, right?
Okay.
With time. So when you place phi here, what does this mean? That means phi is changing with the time, right? You understand?
Yes.
Okay. So let me explain something else. Okay. I need. Okay. Now what is so d phi by dt is clear for now.
Yes.
That means theta. I mean the phi is changing with time.
Yes. Changing with time.
Huh?
Yes.
The flux is changing with time. Phi is the flux, right?
Yes, I know.
When the okay, if there is no okay, when you have n phi that means what? N is here and
phi-
flux is here, but
there is
nothing
no
changing.
change in time.
There is no changing with time,
Yes.
right? Okay, you come. I'm going to show something. Let us take. Okay, come here. Let us take her as maybe she is n. I mean the number of terms, and I am phi. And if you think about n phi, it's here. Come here. Okay. We are now at n phi state.
Yes.
That is not producing electricity.
Yes.
You do not see zero out there. So when I'm staying with her beside, nothing is gonna happen.
Yes.
Right? Okay. Now, if I'm changing my position with her with regard, because she is n
Yes.
and I used to be the phi, right?
Yes.
And we used to be n phi like this,
Yes.
no changing
No
with the
changing.
time, right?
Yes.
But when I would change my position with the time like this, sometime I'm here, and
Sometimes
after
you don't.
some time I'm here, and after some time I'm here, right? So that means what? We are in a state of n d phi by dt.
Yes.
N d phi by dt. This is. You see that?
Yes.
And she's n, and I am phi, and we are now in a state of n d phi by dt. So n d phi by dt means there is always a relative motion between n and phi. When there is a relative motion between n and phi, only then the electricity will produce.
Relative motion.
Yeah, relative motion, that means she is steady, I am moving. She is stationary, I am moving. Or I am stationary, she is moving. That means there is always a now she is changing, right? I am stationary.
Yes.
You understand?
Yes.
So it would be either n d phi by dt or phi d. That means phi dd d n.
Yes.
That means it has to be changing. We cannot stack like this. We have to. Someone has to change his position, his or her position. If that happens, then only this condition fulfilled. n d phi over dt. That means n is stationary here, and it can be either n can be stationary or phi can be stationary. Any of them can be stationary, but there should be a relative motion between them. One would be stationary, other would be moving, or this would be stationary, this would be moving. You understand?
Yes.
Okay, you get it from there. Now, do you understand? So this is an arrangement
Yes.
where there is a relative motion between the number of turns and the flux, right? So if we have a number of turns and around that there is flux changing, then the electricity will be produced. Where we see the electricity? We understand that when there is a n and there is d phi by dt, electricity will produce. But where we will see electricity produced? Where? Yeah, inside the n. Inside the n, electricity will produce. That means n was what? The number of turns, right?
Yes.
N was what?
And it's the time.
The number of turn.
Yes.
Right? So when you have the number of turn, and this is the phi is there, right?
Yes.
When you make something like this, then electricity produces. Now because n and then d phi by dt for now, because it is changing,
Yes.
right? But right now they are in n phi state because this is the phi, and this is n,
Yes.
and they are in phi.
That is N5.
But when it moves, it becomes n d phi by dt, right?
Yes.
So once n d phi by dt condition fulfilled, then electricity produce according to this law, right?
The inside of the N.
Inside of the n, inside of this wire, because this wire is the n, right?
Yes.
You understand?
Yes.
Everything is clear?
Yeah, clear.
Now we would like to see directly whether once we make this arrangement, electricity is produced or not.
Okay.
You understand?
Yes.
Okay. Now let me explain you this. We have. Do you see that? This is a module.
Yes.
When we have this one, this is a wire. Huh? Do you see? Yeah. You see here? Look at this. Look at this. This is wire. This is one wire which comes in, and there are some number of turns. The number of turns is insulated with the
Yes.
insulator.
Yes.
Right. So the wire comes in, and there are some turns, lots of turns,
Okay.
and the wire comes out here. Right.
Yes.
So this is N. Right.
Okay.
Because one wire comes in and then make a coil, forming lots of N,
Not the N.
and the wire comes out like the same I have shown. The wire comes in. You see this wire. This wire come. Okay, let's see. Let me explain. This wire. Okay, this wire comes in.
Yes.
The wire here comes in and form lots of turns, and the wire comes out here. So this is comes in, and then form a kind of N, and it comes out, right?
Yes.
So this is what I can tell. The wire comes in, lots of turns, and it comes out,
I
right?
understand, I
So N is here, right?
Yes. Very good.
And phi is here. We have already seen it in the magnet, right?
Yes.
So now these two are in n phi state, right?
What?
N phi, N and phi, they together.
Yes. Yes. There is
But
no big
yeah,
time.
right. But right now there is no electricity.
Yeah.
But when I move the phi,
Produce
around there,
electricity
then electricity produced where? Inside the N.
inside of the N.
Okay. When you and then how would like to see whether electricity is produced or not?
What?
Okay. How would you see the electricity? We believe that the electricity is produced here,
Yes.
and the mathematical equation shows the same, right?
Yes.
The mathematical equation shows that when the N and phi there is a relative motion in between,
Yes.
electricity produces inside the
Inside
N,
of
right?
it.
So what was the N? This one.
Yeah.
So inside this electricity produces.
Yes.
But how would you see that? How would you see that? You know that it produces, but can we see?
No.
We cannot see.
Yes.
So how can we see that? Using an ammeter, because ammeter is giving the rate of charge flowing in a current.
Yes.
The measuring instrument for ammeter for current is ammeter. The measuring instrument ammeter measures current. Yeah.
Wait.
So okay, ammeter. This ammeter. Ammeter is the measuring instrument. Measuring instrument.
Measuring instrument means
Instrument means a device, measuring device that measures the current.
yes.
Ammeter is a device that measures current. You understand?
Yes.
Ammeter is a device that measures
Current.
electric current. You understand?
Yes.
So now we see the electric current is produced here. If we connect an ammeter with the N, only then we can see this, right?
Yes.
You understand?
Yes. Very well.
Okay. So the N was what? The N was this number of turns, right?
Yes.
The wire comes in and somewhere. This is the end,
Yes.
right?
Yes.
And we will make the phi available here,
Yes.
the magnet.
Yes.
The phi is around the magnet. So once we change the magnet around the end, electricity has to be produced inside the end, right?
Yes.
Okay. So if we connect, this is the two terminal of the end, right?
Yes.
So if we connect an ammeter here, like this, ammeter is symbolized with A. If we connect the ammeter here, so once electricity flows, it will flow through the ammeter. Okay, once electricity is producing here, right?
Yes.
The electricity will run through this way. Huh?
No, the emitter.
Ammeter, the ammeter is connected here right now.
Yes.
So once you connect the ammeter, so as the electricity travels, it will travel this way. The electrons will travel this way, right? So it will travel inside the ammeter, and that is ammeter will show you that this is electricity flowing.
Yes.
You understand?
Yes.
So once
The
you connect,
electricity, they enter the inside of the emitter.
yeah, ammeter.
Then you see the
Yeah,
electricity.
so if you connect the ammeter with these two wire of the end, then you know when something is produced inside this will flow this way, and emitter will record.
Yes.
You understand?
Yes. Yes.
Okay.
Then emitter we see the electricity.
Yeah, in the emitter we see the
He
electricity.
tell us the electricity on or off.
Oh, yeah. You see that?
Yes.
Okay, now come here. I would like to show you this arrangement.
Okay.
Okay. Come, this is the emitter. This meter is
Okay.
emitter. Okay.
It's emitter, I understand, but this is
Measuring instrument. The instrument is a device.
this device is called the emitter.
Emitter, right? And it is used to measure something. That is why it is called measuring instrument. Instrument, you know, instrument is the device, any device.
I know.
Apparatus, apparatus.
Yes. Okay. Measurement.
Measuring means measure. To measure something. You know, I'm measuring your height, maybe this. I'm measuring your weight. I'm measuring your maybe the size of collar. That's the measurement.
Measurement.
Yeah, that's what I'm telling. Measure.
Measure.
Yeah.
You call it like J. I know measurement.
Okay, measurement. Do you know that?
Yeah.
So this is measuring instrument. Instrument of the device of measurement. So you measure current using this current, right? Okay, current that means the ammeter. You see AC, alternating current meter. So in milliampere range, so I will understand what make you understand what is the unit milliampere, right? Ampere is the unit of current. So milliampere is a small range. Okay, because it's a small generator, right? Good. Okay. So this was the end, right?
Yes.
So this is two terminal. This is one wire. This is another wire. This wire is connected to this, and this wire is connected to this. You see, this is some kind of term. This is the circuit. It's a diagram. The practical thing is this.
Yes.
So this one is connected to this, and this one is connected to this. So once you connect the ammeter according to this, one is with this, which means this one is connected to this,
Yes.
and other one is here, which means this one is connected to this,
Yes.
right?
Yes.
Okay. Right now, look at the ammeter. So this is N, right? N is ready. Yeah. Do you see? No. Here. Do you see? This is the N, right?
Yes.
And this is the magnet where the phi is available,
Yes.
right? So when they are together like this, you
Yes.
see N phi. Nothing is produced,
Yes.
right? But if you make the N moving, you see electricity is produced here. Huh?
Yes.
That is how electricity is produced, right?
This is the number.
Yeah. This is the number of
Of electricity.
electrons flowing, coulombs flowing, right? Coulombs is the lots of electron together called a package, which is called coulomb. If you think of 1 kg of salt, which means lots of salt inside a bag, right?
Yes.
A packet of salt, which means maybe thousands of pieces of salt inside the packet. So coulombs is a packet where lots of electrons together in a packet. So the number of coulombs passing per second is ampere, and this is milliampere. See, the more I am just rotating, the more current is flowing. But
Go up.
Yeah, but when there is no motion between N and phi, which is N phi, that doesn't produce electricity.
Because it is after the off D.
Yeah, ddt. Yeah. So when it is
When you
moving,
make any action,
yeah,
the DT
now
will come.
ddt, right? N d phi by dt. Now this, so once we fulfill this condition, electricity is produced, right?
Yes.
Huh?
Yes.
And is that true?
Yes, true for you.
Huh? So okay, now this is the generator. The generator you see everywhere the electricity producing. This is the generator.
This is
Yeah. Now can you make a generator?
yes.
You need a wire, you need a
We
magnet.
only need magnetic and
Yeah,
and
and
N
wire.
and this only to know this number.
Yeah.
I like this thing.
Yeah.
Very
Okay,
easy.
it's very easy, right? So that is how every generator is produced. Okay, let's see it explain.
Okay, thanks.
So I think today our time is almost over, right? What is the time for now?
5.
Huh?
1.
Okay, 1 so we don't have much time. Yeah, we have only 5 minutes. So I don't think we should go much further. Just study on this today.
Okay.
On the next class, we'll go to the practical generator, the big generator, and we'd like to see whether whatever we have seen today
Okay.
is there or not, right? And I will explain how this generation is related to this coal, oil, and gas.
Okay.
How exactly we have talked about generator function,
Yes.
but we have not talked yet that how the coal or oil gas is used to generate the electricity.
Okay.
So far I have shown this equation. This equation we have proved it practically, right?
Yes, very well.
But we have not seen that how the generation of electricity is connected with the coal, oil or gas. This is what we will see in the next class.
Okay.
Understand? Okay, thank you so much.